Welcome back. Today's going to be a really exciting day because we're turning this little guy, into the same thing but in C#. It's going to be fantastic. And I actually had a theory that my game was compiling slowly because I'm running off of a disk drive that isn't my boot drive. So I'm going to try to move the game over to a different drive. I'm going to try to move the game over to my boot drive and see if that fixes the issue. So let's take a look at this. So right now, it takes roughly this long to load. This is excessively slow for a computer this powerful. Yeah, that was ridiculous. So alternatively, actually, Alternatively, let's try and copy the game over to a local folder. So I'm just trying not to leak my file systems to you guys. We're going to do this real quick. So game dev, engine, juicy game. Yeah, so this whole folder I'm going to move to, I don't know, my documents folder maybe. Let's see, is this good? C drive, users, me, documents. Yeah, let's just do a new game dev folder. And I'll close out of Visual Studio here. Okay, and then let's launch Visual Studio. And I'm just gonna hope you guys don't mind me not leaking my entire file system a second time. Let's see if it's any faster. That'd be awesome if it's faster, because I don't like sitting there staring at it more than you guys do. Open a project. Documents. Game dev. Juicy game. Here we go. I just moved the entire game screen. Yeah, I just moved OBS. It was in the background when I double-clicked. That's stupid. Okay, let's see if this is faster. Man, it's still not as fast as I'd like it to be. Unless I had... Hold on. Was I accidentally pausing the command window? I might have been. No, it's just ridiculously slow. I will have to look into this. That's not terrible though. That's okay. That's okay. Okay. Yeah, I think we're doing all right. Let's start the stream. I'm just gonna do a run. Why not? Just for funsies. I made a fool out of myself on the first stream by not being able to win the game a single time. So let's see if I do any better today. I got this. It's gonna be a speed run. We're gonna kill these guys as fast as we can. Come on. Oh, okay. I'm gonna just embarrass myself a second time. It's fine. It's a strat. You get really close. Sometimes you get hit, but it's worth it for the damage, you know? Yeah. Yeah, you get it. You understand. Let's take these guys out. See? Look at that. We get hearts. And everything's alright. I cannot aim. Oh my gosh. I thought I got them all. I didn't think those projectiles were going to hit me. Just if I move my microphone in front of me, and then I can kind of game at a nicer angle. And of course, you guys will let me know if I'm too loud now. Or maybe you'll just turn the stream down. That's one way to do it. Am I going to lose? Okay, I can do this. Look at that. 7 baddies. This is the run. Here we go. Look at that. I'm not going to get hit a single time after that one time. That's what's going to happen. Okay. Let's do it. Yeah. I'm not going to get hit after that, though. That was the last time I'm getting hit. For sure. Oh, I should have gone for homing. What am I doing? I'm already throwing. 16 baddies isn't too bad. I just have to not stay in one place for too long and not run directly into projectiles. And I should be okay. Wow. I should pick up some of these hearts now. It'd be really embarrassing to die twice. It's not like I have ever died twice on this game. That'd be weird, right? That'd be weird. Okay, last guy. There we go. Okay, hopefully I get homing again. Yeah, I kind of choked by not grabbing that on the first run. Just because... Look at that. That's awesome. That's great. Love to see it. Okay. I'm just going around. Just no reason to stop firing. There's always a chance that one of my projectiles hits a baddie. And that's what we're looking for. More fire rate. If I could just get fire rate for the rest of this run, fantastic. That'd be awesome. Maybe I don't want to do that, though. Getting max fire rate might spoil it, because max fire rate is kind of nuts. You might say it's extremely juicy. But... Alright, good. We're making moves here. Yeah. Buzzing noise. Me when I'm buzzing. Oh no. Okay. Okay. We're gaming. Things are happening. Things are happening. Yeah, we love corner glitching in our own game. That is probably one of the bugs of all time. It doesn't even make the game that much easier, so I'm leaving it in. You know what? Obviously we want speed in this situation. Obviously. Yep. I'm really glad I went for speed in this situation. Oh my gosh. I am clenched. Oh. Okay. I can't believe we survived that with full health. That was crazy. That was actually insane. Oh! Oh no! Wait! Oh, there's a heart here too, wasn't there? No! Whatever. We'll be okay. We'll be okay. I'll get that heart back. Yeah, now we got these guys to deal with. Oh my gosh! That's crazy. No way! I only have one more floor to get health back. I don't want to go bonkers. Alright, multi-shot will literally double our DPS right now, so that'll be good. Yeah, this is great. And if I could get 2 hearts out of this and go into the boss with full health, that would be amazing. Of course, there are juicers that just set your health to 1. Considering how poorly I play the game, I don't know, maybe I would play like a little more carefully if that was a thing. But just like the rest of you, I find it hard to believe that I'd be able to do that. Somebody will be able to do that though someday. Oh, that is it. Let's go! Gaming. End friction. Perfect. Perfect run. Just take this guy out. Wrap it up. Okay, I don't want to drop his health to 1/4 because then I won't be able to dodge his laser, because he puts up those walls and it means I have to run around this whole thing. It's a lot harder to dodge the circular laser when you're having to run around that gigantic wall. Okay. Okay, I'm kind of dodging today. And his defenses are down, so I can start shooting at him again. This is perfect. Get him down to 500, because I don't want to see him dashing or doing the laser again. Perfect, perfect, perfect. Just keep dodging like I did before, and we'll be okay. It should be easier in the position he's in, too, because I have a lot more time to dodge those projectiles. This is great. We're almost done. We're almost done. We're going to get it. Finally going to have a successful run in my own game. Okay, okay, okay. That was actually kind of scary. But we're good. Oh my gosh, that totally could have hit me. I kind of got lucky there. And this is it. This is it. Oh! I'm so glad. So, there used to not be anything projecting where he was going. And this attack was basically impossible to dodge. It was just pure luck. Okay, we did it. We're in there. Five minutes. That's an okay time. That's an okay time. Oh my gosh, my upgrade just looks like a big F. No. I finally thought I succeeded and I got an F. That's good though. That's a 5-minute run. You guys got to see the game. There's some desert content here, because why not? Right? Wow. Wow, I'm not hitting at all. Anyway, that's good enough for desert content. That's not what we're here for. Today, what we're here for is making a big swirly tornado. And there's already a couple of things that I want to do differently when it comes to putting together the tornado. So, first off, I want each particle to be its own type. That way, so in GameMaker we had to do some, oh, there's a guy again. GameMaker we had to do funny things. If we go into our tornado object, we just had a bunch of arrays that sort of represented the particle. Well, each index of the array would represent a particle. We're not going to do it that way in C#. C# lets you make actual classes. So what we're going to do instead is just have a class that is the tornado particle, and it's just going to have all of these values internally. So rather than having a bunch of 2D arrays like this, we could actually just have one 2D array that is all of the particles on each ring of the tornado. So let's get back in there. Right. So we're going to need a few things. So right away, we'll need a tornado. So this is really messy. I would not make a game like this in the future. Okay, I'm going to put a disclaimer now because I made this game a little bit ugly. The first time I was making this game was in GameMaker. I literally did it in 4, maybe 5 days just to pump out a YouTube video as fast as physically possible, never thinking that I was going to make a longer game out of it. So I knew what my scope was. I did a lot of things just to get to the end that make it harder to continue working on the game. And then I had the opportunity to fix all of those things when I moved the game to C#, because I literally had to reprogram the entire thing. I could have fixed all of that, but I kind of wanted to see how close my engine was to just a one-to-one copy of GameMaker. So I ended up duplicating all of my mistakes just to see if it would still work. And it did work. The game runs on hopes and prayers. So that's the current state of things. So when you see me trying to find an object in this giant mess of unsorted objects, or digging through code that looks like this. What is this? My console is almost 2,000 lines. Now you know what happened. Anyway, so this tornado, actually, this tornado is not an effect. This tornado is actually going to be a type of baddie. Sort of. Not... It's not going to be a baddie that's listed in the Baddiepedia, the encyclopedia of baddies, the bestiary, if you will. It's going to be more like the sinkhole in Boss 2. So, Boss 2 is a worm, and he creates these sinkholes everywhere that will suck you in as if they have gravity. So, I'm going to copy some of the code that I used for that and maybe generalize some of it so that I may never make another baddie like this in the future, but generalizing it will maybe make it easier to code this right now. So I guess we'll see. What does my sinkhole object already look like? So we have some timer, which this is actually how long the sinkhole itself lasts. Not sure what segments is. Do I actually use this? Where do I use segments? This is drawing to canvas. Oh, right. So the sinkhole has these layers of spinning discs to make it actually look like it's rotating and the sand is sinking in. And the number of segments is just how many of those discs I include. Because the sand background is already very noisy and grainy, I only need a couple of segments to make it look convincing. If it was something more obvious, I would probably need more segments. Something that was easier to look at, I guess. If that makes sense. Maybe that doesn't make sense, but... Anyway, that's what segments is doing. Sand sprite is the sprite I'm using. Canvas is canvas. Spiral scale is spiral scale. Maybe I don't need any of these. Sorry, I just said everything is everything. Sand sprite is the image I'm using for the sand. Canvas is what we draw to. So last stream and the stream before, we saw GameMaker uses surfaces. C#, FNA, and my engine use something called a render target 2D. And I like to just call it a canvas, because I think canvas is a generic term that a lot of other programs use. Spiral angle isn't even being used, so I'll ignore that. Lifespan. So this is 600 game ticks, which is 60 seconds. Sorry, 600 game ticks, which is 60 ticks per second, so 10 seconds total. This is how long the sinkhole will actually last on screen. I haven't 100% decided what I want to do with the tornado as far as sucking things in, but maybe this is all stuff that I do after I have the effect working. I'm not really sure. Or maybe I just get like a circle working and then put the effect on top of it. So regardless, I guess I'll go to baddies here. I'll go to my baddies folder. And I did another terrible thing. All the baddies are just numbered from 1 to 11. And that's not even an indexing thing. I could have given them an actual name and it would have affected nothing, but I decided to be stupid. Anyway, let's create a new object here. This is going to be OBJ Tornado. Tornado. And this is kind of going to be a baddie, but kind of not really, so let's see. The sinkhole does get the baddie parent. Yeah, I think I'm going to code this as a baddie parent. What's good about being listed as a baddie parent is it already has the collision ready to go. So I may regret making it a baddie parent later, but for now we're going to do it this way. So, and I might actually put another object in, or another class in between those, which is just things with gravity class. I don't know. We'll see what it ends up looking like. So this is going to be OBJ baddie parent. Whoops. OBJ. Oh, I still have the mic in kind of an awkward place. I thought this would be the way to go, but there we go. That might be okay. I hope that. Oh, this is very precarious. The mic looks like it's about to fall into my lap. That'll probably happen later. It's epic foreshadowing. Baddie parent. Why is it... Oh, yeah, it's mad because I don't have all of the things that are required for a baddie parent. So let's copy as much of this as we need, right? So tornado. Now the sinkhole I have always in the background. It kind of makes sense because it is in the floor. So I have the depth to 9999 whatever. But I think the tornado, it makes sense if you're able to stand behind the tornado, just visually. So I would like to do something about the depth for that one. I think, oh, maybe if I just go to baddie parent? Where am I setting depth? Baddie 1. So this is the green slime. Where am I setting depth? Okay, so I do set depth in the individual baddie. It's in the do update event. So let's just do that. Let's grab that now. That's fine. Object tornado. Tornado, I might want to set the depth in the create method just because the tornado is going to be kind of massive. I think for the most part, other baddies... I just don't want single frame visual glitches. So for a singular frame, the tornado is going to be behind something that it should be in front of. Nobody likes that. So let's do a do update. Override do update. And then set the depth in there. Now I've got all these sand sprites, which are not necessary or part of it. Although maybe I should use... I could use a sinkhole just to see where the tornado is. Oh, and then I will need a hitbox later. So we'll have to do that. Pull force is set to 0. Can collide is false. Tangible is false. So that's just okay. On creation, can collide is false, which makes sense for the. That makes sense for the sinkhole because the sinkhole can literally appear on top of you, and I want to give you a chance to run away. I'm not going to have the tornado able to appear on top of you, so can collide does not need to look like that. But the real question is, does this get set to tangible true later? No. Okay, so tangible is always false. This does get set to true later though, right? Yeah. So tangible is false. Let's use the same knockback. HP 10 doesn't really matter. Nothing's actually able to hurt the sinkhole or the tornado, but it needs some sort of HP. I think this is what I just copied. Yeah, it is. It needs some HP if it's going to inherit from baddie parent. Otherwise, it's just gonna die immediately because it has 0 health. The pull force is 0. So these are some of the things that I'd like to... Yeah, I'd like to make some of these more generic. It's like this pull force thing. What is this no heart? I think I would know what these are for, right? Try generate, help, like, okay. And then when would this get set to... So, when sinkholes collapse, they will generate a heart. They have a 1 in 10 chance of generating a heart if you are low on health. So, why would no heart be true? I'm not sure. I'm not going to worry about this right now. So, I do need some sort of hitbox for the tornado. Maybe I'll just use the player, like the generic hitbox, which I believe is the player hitbox normally. So, like, mask is player hitbox. I've been doing that for pretty much every single baddie, and it works great. It feels fair, because the player has kind of the same hitbox as the enemies. It ends up working out. And just for fun, I am going to make the sprite the same as the mask, but later on, I think we'll actually have no sprite, because we're just going to be generating the particle effect. But this is just so I can see the tornado in there. Pull force, I guess I can create the pull force value right now. And then, so pull force in the sinkhole does get set to something else, right? Yeah, pull force gets set to 2F later on. Yeah, it gets set to 2. The F just means float, so it gets set to 2. 2.000 as soon as the game starts, which makes sense. So I should wait to do this until the tornado is active. So I'm gonna leave it as 0 for now. But what I'd really like to do is plop a tornado down somewhere in the level just to show that it's working. So if I run the game right now, what I'd like to see is the player position. So I actually already have code that I've left commented out on the player. And that code tells me where the player is standing. It pastes it into the console for me. So let's go find that. That's going to be something position. No, actually it'd be like right line. Let's do right. Yeah, this is it. This is the one. Wait, no. This is just my speed. This is fine, though. This will work. So I can do console.WriteLine. Actually, what am I even doing? I don't need to do any of this. The whole point was I just wanted to put the tornado near where the player spawns. So I'm just going to run the game and set a breakpoint once I've loaded into a level. I'll just read the position from there. I'm doing way more work than I need to. So run the game. Here I am. Breakpoint. And our position is 560 by 350. So if I put the tornado at like 520 by 310, just like up and to the left above the player's head, 40 pixels, that should be really good. That should work out for me. So let's go to scenes, area 1. And I'll literally just create a tornado right here. So I believe it's obj create. Yep, object create. Tornado. And then at position, I said 560, so 520, 310. Oh, it's got to be a vector too, right. Numvec2, 520, and then... Oh my gosh. I have a calculator button on this keyboard, and it drives me up the wall, because I always press it when I'm trying to hit backspace. Oh, and this has to be defined as a new numvec. So, okay, we should have a tornado there. Should be visible. I just want to make sure it's there before I do anything else. And while that's loading in the meantime, we can actually continue coding other things, sort of. Right, so in the player, well, it finished loading, but in the player, the way things with pull force work is it's really stupid. There's two things in the game that have pull force. This thing called Batty 9 and this thing Sinkhole. And yeah, rather than just having something general that can pull, I am individually looking at each of them. Now, okay, Sinkhole is a little bit of a special case, I'm realizing, because it doesn't have this start or moving. But Tornado will have that. Tornado will have both of those. It's going to be just like a regular Batty. So I'm thinking what I'll do is I will make Batty 9 inherit from Gravity Baddies, we'll call them. Gravity Baddies. Or Gravity Batty Parent, or something like that. And that way we can reuse all of this code instead of having to make something new. And literally Just keep adding to this. Like, just keep adding to this forever. That's not what you want to do. So there's our guy. That's our tornado. Oh, and it also has a lot of knockback. Yeah. Yeah, and I just simply died because I'm bad at the video game. Okay, that's good. That's fine. Let's make our new parent. So this will be OBJ Gravity Baddie Parent. Parent. And this will inherit from OBJ, oops, Baddie Parent, just like everybody else. And I'm going to try to inherit as few actual things as possible. This might be most of what I need. So if we go to player, position is already an inherent part of being a game object, just in the engine at all. And then the start and moving come from the Baddie Parent class. But this pull force comes from our gravity parent. So this is what we want to grab. So I'm going to leave Sinkhole as not part of the gravity parent just because I don't want to mess with it. But all the rest of these we can absolutely do. So Tornado, instead of being a Baddie parent, this is going to be a gravity. And then what we want to do is take away this pull force and put it here instead. So now, and actually, I could just set pull force to whatever I want, because if the baddie isn't started or moving, then it's not going to be pulling the player. And that was kind of the main reason that I would set pull force to 0 in the first place. So let's set that maybe to 2 right off the bat. The other thing I want to check, though, is if we go to Baddie 9. So Baddie 9 also has this pull force. We're going to get rid of this. So the pull force on this is 1. That's actually less than the Sinkhole. For some reason, I thought it'd be more. But, okay, so that would cause problems, except that we're going to... Oh no! Baddie 9 also inherits from Baddie 2. So I can't make it inherit from... I can't also make it inherit from a gravity parent. Okay, then I'm going to make this easy on myself. We're just going to go into Baddie parent. We're going to give it a pull force value. And we're going to give it a... public bool has gravity. And so now everybody in the game has the ability to have gravity, and we're just going to set it to false by default. That's it. Simple as that. So now when we go back to Baddie 9, yep, that's our gravity guy. There's really nothing that needs to change here, except he has gravity. Has gravity is true. We don't need to set the Sinkhole to has gravity is true because that one's already being done separately. So we go to, now we want to go to the Tornado, which is here somewhere. Where'd my OBJ Tornado go? Here we go. Tornado. Oh, it was there the whole time. I wonder why I lost it. So, has gravity is going to be true. That's not how you spell true. True. And it is just going to be a regular Baddie parent. And we're just going to delete the gravity one. Don't need to have that at all. Where are you? Where are you? Where are you? Gravity Baddie parent. Get that out of here. So, yep, that's gone. Okay, so pull force is 2 on the Tornado, and has gravity is true. And then we don't want to break other things, so Baddie 9 has gravity is true. And I'm actually just going to put this, just so it's Everything's kind of near. It's like items. Wherever I have... Oh, did I never... Ha, I never added pull force back after deleting it. Whoops. God, I checked. This was 1. So we're good. So now we go back to player. And rather than being baddie 9, this is just going to be all baddies. So baddie, parent, baddie... Oh my gosh. Baddie, parent, 2Ds, parent. There we go. So if not start or not moving, and we'll add another has gravity. Obj.has gravity, my bad. Obj.has gravity. So if it doesn't have gravity, we're going to continue. If it's not started, we're going to continue. And if it's not moving, we're going to continue. Simple as that. So now I need to remind myself how these guys get started. So right here. So this if start. So when do we set start to true? That's kind of the question. I can't remember if player sets start to true on everybody. Yeah, okay, I think player does do that. But then there's the other one, which is moving, right? If I go back to player. Yeah, moving. Sorry, I had to sneeze. Come back here. Right, I'm on the wrong guy. Where's my baddie 1? Where'd he go? There he is. Okay, so maybe I'm not worried about that, potentially. When does moving get set at all? When does moving get set? So if aggro is true, and if distance is closer than accent distance. Okay, so if the player is close to any baddie parent, it automatically gets its moving set to true. So we might be done here. We might have all that we need. So I'm going to run this and see if the tornado has gravity. And this is another example. If I had set this up properly when I redid it in C#, I wouldn't be asking all of these stupid questions now because I don't know how my game works. Haha, very funny. I would say there is currently not gravity, but let's see why. So I'm going to set a breakpoint here. And then, so I just want to see the tornado. So if I hit OBJ, so that, yeah, OBJ, if I look at the type for OBJ, it'll tell me that it's a baddie 1, so that's not the one I want. I'm going to continue, I'm going to continue, I'm going to continue until it says tornado. Actually, there's 9 baddies, so I shouldn't have to press continue more than 9 times. There we go, there's the tornado. Tornado has gravity. It is started, but it's not yet moving. So I got to figure out why it's not moving. It's kind of what I expected to see, to be honest. Unfortunately. So where's baddie 1 again? There he is. Okay. So, actually, I guess the better question, you know what I can do? I think if I go to area 1, this level generator, right here, spawn baddies dungeon, where I am spawning baddies at all. I'm going to comment this out so that no baddies spawn, in theory, hopefully. And then I'll only see the tornado because the tornado isn't getting spawned normally. I'm manually spawning it in. Yeah, and it shows 0 baddie. Oh, but I only have like a split second to play with it because it already starts fading out. That's fine. That's okay. Is that okay? You know what I'll do? Just for now. So the reason it's not being counted in the total is because it's not tangible. But just for now, I will set tangible to true. So now I will actually be able to play with the tornado. And now that it's the only one on the screen, I can check things more easily and do some other debugging. So, for example, and actually the reason I'm doing that, if I go into damage parent, so if I run the game, at this point I'm expecting to be getting sucked in, and I'm expecting that move should be true. So let's find moving here. So player close, right? Interesting. Is the player close method even getting called? Oh, it's not. I have to call it myself. Okay. So if start, then I check for player close. And then this is when I can add my like moving code to actually be doing stuff. Okay. It's great that I don't remember how my game works, but you know, no one has to know. Tornado. Paste that in there. So if start, and none of this is necessary because just doing the if check for player close is going to set us to moving if we should be moving. So let's run that again. I like how I didn't have to do any of what I just did. Just where I was going to set the breakpoint made me immediately realize what the issue was. That's what I have you for, chat. You guys are my rubber duckies. Rubber ducky chat. So now I should be getting pulled in. Oh, I'm getting pulled in vigorously. Like, oh, at that distance, I actually can't even escape. Wow. But I can hit it. Funny enough, I can hit it. Which is not something I should be able to do. So, I want to see some, like, movement speed. If I get movement speed, can I outrun it? I know I can with friction. If I get max friction, then this weather event literally doesn't matter at all. It gets ignored. Okay, not literally. The way friction reduction is calculated for gravity things is... Oh, wow, that worked really well. Oh, and I instantly died. Whatever. We're good. I was going to say, the way gravity reduction works for friction is asymptotical, so even when you have really, really high friction, it still pulls you by less than a pixel per frame. Eventually you get pulled in. Anyway, I think the issue here is pull force is way too high. That's the pull force for a boss when it's expected that you already have some friction upgrades and speed upgrades. So the weather's going to be random events. So if you spawn in on level 1 with a tornado, you're instantly screwed, which is probably really bad. So it is possible. If you're too close, you will end up getting sucked in. Like if you're at this point, I can't escape anymore. I'm too close to escape. But at this point, I can just barely escape. And then at this distance, it's not pulling on me anymore at all. At this distance, it is pulling in. It's pulling me until I get right there. Then it stops pulling me in. Yes, I'm getting pulled in. And then, of course, because of the way aggroing works, if I were to shoot at it, it starts pulling me in just because it gets aggroed for 3 seconds. But then it stops being aggroed. Let me see if I can hit it from here. Yeah, I got pulled in. So, Tornado's not a normal baddie, once again. And I do want the Tornado to be pulling you in from pretty much anywhere. So I am actually going to set aggro to 1 forever. It will always be aggroed. So, where's my Tornado? So in my update, we are going to set aggro. Actually, okay, so it should be... Oh, but I already have it as a player close thing, so if it's moving. Hold on a second. Does this return true if aggro? Oh, yeah. If you're aggro, it does return true. So we're good. So if the tornado has started, then he is going to be aggro forever. So aggro time is going to be equal to 1 forever. And when do I reduce aggro time, actually? Just to make sure I'm not doing that at an inopportune time. Parent do update. So, yeah. It's fine. It doesn't matter. I mean, obviously, if I set aggro time to 1 immediately before I check this, which is what I'm currently doing in the tornado, then it won't matter. No issues. Doing all right. Okay, so now, oh my god. I got sucked in immediately and I couldn't escape. So yeah, now no matter how far away, like I said, it's asymptotical, so even if I'm all the way over here, there is still like a little bit of suction. And it's not even that much more as I get closer. But when I get really close, now it's really pulling on me. And I just want it to be something where it affects the player. So I guess there's a few things I could do. If I'm having the tornado constantly follow the player around, then this is probably a good pull force. But another thought I had was just to have tornadoes constantly spawning in, moving across the screen, and then getting destroyed, which might end up working well. And if that's the case, then I can probably set the pull force to be higher because the player's not going to be constantly running away from it. There's a decent chance that it'll be easy to avoid. But I don't know. This is the kind of stuff that I'm going to polish the game when it's all done and set. Oh, that was interesting. When I went against the wall, I went a lot faster. Oh, wow. That's really interesting. I'm not going to fix it, but it's really interesting. Anyway, yeah, so there's a lot of things that... A lot of just playing with numbers. At the end of the day, game design, the last thing you do is spend time playing with numbers. Oh, interesting. If you get stuck right there, you don't even... Wow. Okay, there's some mild glitches with gravity, but I'm really not too worried about it. Mostly because I'm afraid of what it would take to fix. But for now... So that's interesting. So at any angle that happens, that's really weird. Oh, no. This... Okay, I did end up getting stopped there. Oh, because when it pulls on you, it's not doing the thing where it snaps you across the wall like if you were moving. If you're moving, there's a little bit of leniency where you could run into a wall, like clip it by a pixel, and the game will just push you up or down to make it so that you can keep moving. Just a little bit of forgiveness. It feels good. Anyway, I don't really hate this. I think it's good to continue working on. So that's fine. Maybe I'll just make the pull force like 1.5 and see how that looks. I know I said I wasn't going to mess with it anymore, but I was thinking I was going to make it 1.5 and leave it alone from there. This is it. I'm not messing with it after this. I swear. I just wanted to make it 1.5. You know, so it's more noticeable. For testing. Yeah. It's all good. Whoa. Holy whew. Okay, 1.5 is a lot. Can I even escape it right away? I can. I can escape right away. But that's a big difference. Because it ends up getting squared too, so. Yeah, if I go to player. Well, I thought pull force ended up getting squared. I guess it's linear. Anyway, I need to use the restroom, so I'm gonna... put this up here for on the off chance that someone joins the stream using rest room. And then if someone doesn't speak English, I'll like add a little drawing so that they understand what's happening. Okay. BRB.
Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Finding life along the way, melodies we haven't played. No, I don't want no rest. Echoing around these walls, fighting to create a song. I don't wanna miss a beat. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go.
All right, we are so back. Oh, my mouse is not on though. Here we go. Boom. Get that out of here. So, we have this going on. Next up, we're gonna actually make the effect. Woohoo! Alright. Classes. Juice, predict launch. So I'm going to want a class for individual rings, and then I want a class for the particles. And I have a feeling there's going to be additional particles, like smoke that gets blown out and things. So I think it's actually worth making a new folder just for the tornado effect. So add new folder, tornado effect, whatever, folder. I'm actually going to start with the particle itself. So this is going to be tornado. We'll call this a spinning particle because there might be other particles later. Spinning particle. And this is going to have a few things that it's created with. So this is a part, areas, where we can open up GameMaker and see a few of the things that we have done up until now. So we've got part speed, initial angle, current angle, color, and position. So what I really want to do is, what I did in GameMaker is I had a bunch of different sub-images of a sprite that were the particle, and then I would just pick one of the sub-images. But for this, I'm actually going to tell it to be a specific color and just color blend with a white particle. So if you color blend something that started out as white, it will perfectly turn into the color that you are blending to. I don't know if that makes sense to anyone who's never seen this before, but hopefully it'll look okay in a second. So we'll do float. All right, these should be probably public. Public, float, a velocity. And this is going to, okay, we're gonna have to set this, so that's fine. So A is for angular velocity. Then we have, I want to make it so I can see both at the same time, because that just makes too much sense. That might be too big. So we got angular velocity, which is going to be speed. Then we're going to have, why are you mad at me? Oh, I'm in the wrong spot. Don't make fun of me. It goes here. Public, float. So, init, angle. Starting angle. Okay. And then we're going to have we're going to have public color. This is going to be XNA color. Don't want to mess that up again. And honestly, color is fine. And then, because C# is not GameMaker, and we actually have vector2, we're going to use vector2. And that is going to be position. And then, actually, this is interesting. So I have a velocity, initial angle. Oh, I don't have the current angle, so we'll do public float, and we'll just call this regular angle. That's good. So that's now 5 things. We had 6 here, but we combined X and Y into one vector2. The other thing I'd like to do is, so in this game, I've been using system numerics vector2 as opposed to XNA vector2, just because it's a little bit faster. And actually, there's parts of this game that really need it. It's pretty bad. But, no, I've made the game very efficient, but that was part of what made it efficient. So what I want to do is, if I just call it vector2 and I add the using for system numerics, it's going to get confused by this XNA thing. So what we're going to do is we're going to say using numvec2, that's where that thing you saw earlier came from, equals system.numeric, nope, that's just nullable, system.numerics.vector2. And now numvec2 is a friendly name for that, and I can simply use that, come on, without it getting confused. So we're good. And that should be all right. We'll have to add some classes to this to get it to work the way we've had the other thing working. So like internal to the tornado spinning particle, I'd like to add this that we had from GameMaker, which is how it decides what its position should be. So in order to know where it should be, it needs to know its initial angle, which is internal. It needs to know its own speed, which is now angular velocity. So again, that's internal. And actually, I'm missing some of it. There you go. And then has a time value. And time is external, so we need that to be an argument when we call this method we're about to make. And then the next thing is going to be current width, and that is the width of the ring that the current particle is on. So that will also have to get fed into the method. So let's do that. So this is going to be a public void update position, and it's going to take float time and float width. Actually, I think width is going to be an integer probably. Is it an integer? Did I bother making it an integer? Probably didn't, actually. Where is my width? Current width array. Yeah, I just made it do regular interpolation, so there's no reason to make that an integer value. I can truncate it later when I'm actually drawing things, but I'm not going to be drawing things of a certain width like I was with the ellipse. I'm actually going to just be placing the particles where they should be, so this can always be a floating value. That's fine. Position is a float. Numvec2 is 2 floats. Yeah, basically. Anyway, enough yapping. Let's get back to this. So, come on. And the other thing I want to be really careful about is I want to make sure that this is parallelizable. So I don't want to be writing to anything that anything else has a chance of writing to. So I'm going to be writing to these values in parallel, but other than when this particle is first created, these values should never get written to other than by this method. So when it's first created, I'm going to set all these initial values, but the only other time they'll get updated is from this method here. So that should be fine. You can read things in parallel, but you can't write to them in parallel. Very important. So let's check this out. So our angle is going to be equal to our initial angle, according to this, right? Oh, plus part speed times time. Yeah, otherwise it would be kind of a waste. So a velocity times the time value we're passing in. Next we have, oh, and then of course we're going to modulo it by 2 pi. So we can just do that on a second line like we did before. Mod equals, and then C# float actually has tau, which is 2 pi, and that is a full circle. Next up, our position is going to be both of these things essentially combined. So divided by 2 and divided by 6, same deal. Let's do new numvec2, and then I want to do this on 2 lines so that it's easy to look at, and you'll see what that means in a second. But basically, yeah, so we have width times cosine, oh, I'm sorry, float.cos, and then our current angle, and divided by 2, because it's to the left and the right of the center point of the ellipse. So whatever the width of the ellipse is, we have to divide by 2. And then, comma, we'll do width, excuse you, times float.sine angle divided by 6. Cool. Neato. Okay, check it out. There we are. So yeah, the reason I want to do this on 2 lines is look how neat that is. Width and width line up, float and float line up. We see that cosine and sine are different, and we see that 2 and 6 are different. That makes it really easy to digest. And we have now updated our position. The next thing we want to do is add a draw. So this is going to be, I'm sorry, please don't get mad at me. Public void draw. And this is just going to take, maybe later I'll make it take an alpha as well, just to be able to change the translucency of the tornado. But for now, it'll just have to take a sprite batch. Sprite batch. And it needs to take the sprite batch so that it knows how it's drawing. So this will be batch dot draw. No, it's going to be, oh, I don't have a sprite yet. So I know I had the silly sprites I'm using here, but I thought I could do better than that. Let me try and move this. So I want to make a better sprite. And yes, I do still use GameMaker for all of my sprites. Unfortunately, it's a very sad situation. 16 by 16 might even be too big. Let's see how I can do here. So this is where we're going to make it all white. And my thought process, honestly, was just genuinely just a few circles. And like maybe that'll be okay. But I do want the ability to drag them around. So let's do this. Put that here. And then another one can go like here. And I think that'll look good if that's what we get. Oh, I'm sorry. So Let's actually call this one Tornado Particle because it's the one we're going to use in the end. Sprite Tornado Part. Paste that in. So this is now 13 by 12 instead of 16 by 16. And I do need to save this into Juiciest Game, but you're not allowed to see my folder structure. Haha. Hold on. I'm doing stuff, I swear. I swear to you. I am doing things. Documents, game dev. I actually just completely forgot where the folder was. That was what was happening there. Then there's lay the Juiciest Game. Classes? No, not classes. I'm sorry. Content. Sprites. Pressing the wrong thing. And this is going to be Sprite Tornado Part. And honestly, yeah, I'm not totally sure if I'm going to have lots of sprites for the tornado in the end. So I'm going to give it its own folder. And then what I have to do is come back over to Visual Studio, which is here. And now, the magic, when I go to Content Sprites, because I moved it to the correct folder, under Juicers, there it is, Tornado. And then I have to change this to copy if newer, so that it actually gets copied to the output directory. And then I need to make... Okay, so let me explain a little bit what's going on here, because this is the first time I've had to add a new sprite on stream. It's pretty simple. So let me just finish writing this. Tornado Part. So the PNG is just the image. It's all white because Visual Studio, but like this is what a different sprite might look like. So the image is just the image, okay? And then this thing, the JSPR, that's supposed to be JSON sprite, has a bunch of, I guess you would say, options, configurations. So Tornado Part only has a single subimage, so image number is 1. Pixel Perfect is collision handling. So if it's not pixel perfect, then the collider will be a box around the sprite. If it is pixel perfect, then if the player like appears here, it's technically not overlapping, so it won't detect a collision. So pixel perfect is pretty cool. I think it's fun. A lot of people argue that it's not necessary, but here we are. This is important. So offset lets me set the center of the sprite to be the actual center. Bounds, X, Y, width, and height. These are, again, for collision. So if I set the X and Y position, then... So if I set X and Y, by default, they are the values you see. But if I set like X and Y to 1, then it's going to ignore the top row of pixels and the leftmost column of pixels. And then if I set the width or the height to something other than -1, then it's only going to look at that, I guess, number of pixels from where X and Y are. So if X is 1 and W is 2, then it's going to skip the first column of pixels, and then it's going to only look at the second and third column of pixels. That's kind of what that means. And then alpha cutoff is, again, only for pixel perfect stuff. And that says if you have some transparency in your image, how much transparency should be ignored when checking for collisions. At 0, it's not ignoring anything. Even anything other than completely transparent will get detected as a collision. And then if you set it to 254, so one less than 255, then only sprites that are fully opaque will get considered for collisions. Now you know. So that's JSprite. And then if you don't use a JSprite, like this background filter doesn't have a JSprite associated with it. Oh, by the way, the JSprite does have to have the exact same name as the PNG. But if you don't have a JSprite associated with your PNG, then it's all just the default values. So these are the default values. One image, pixel perfect is false, offset X and Y are both 0, bounds X and Y are 0, width and height are -1, alpha cutoff is 0, so no cutoff. And one thing I do want to do is give you the ability to edit this data reference file to become the new default. So if you know every thing in your game should collide pixel perfect, then you can set this to true in the data reference and it will be reflected. So that's something I want to add. But yeah, this is looking not bad. So we now have a tornado part, and now I have something to draw, which is going to be sprites, and I need to import sprites. Sprites.get, so this is how I get a sprite. Sprite tornado part dot get. Oh, I'm not sorry, dot get. Dot draw. So that's how we draw it. Batch. Batch, not barrier, batch. I don't even know what barrier is. Actually, wait a minute. What are you? Holds the basic barrier variables. What is this in? This is system threading. Oh, this is a multi-threading thing. I do not know things. Maybe I'll learn about that one day. But anyway, really simply, so we do have to transfer in the sprite batch that we're using. Next is position, so we do have position. Image index is going to be 0. Image blend is going to be our color. Angle is 0. And a lot of these are optional, but image scale, we're just going to use numvec.1 so that it has the scale already. Sprite effects, we're going to use sprite effects.none. And then this is interesting. This is going off screen. I should be able to see everything, but I can't. Wow. Usually it'll go to a second line if it doesn't have room. I'm not sure why it's doing that, but I can just control click on draw to see the definition. So image scale, effects. Okay, and then whether or not I'm using absolute coordinates and all that stuff. I don't need to worry about all that stuff. That is completely optional. So I guess everything after color is not necessary because everything else is optional. I'm just going to delete all that. So now we will just destroy. Now we will draw this sprite wherever we're supposed to draw it. Okay, that's good. This is good for our particle. So next thing that we need to add is the actual ring. So let me close out of our content here. Go back to classes, tornado effect. This is going to be tornado ring. So this is tornado ring. And so this is an ellipse. We need a few things for the ring, I believe. So oh, I just realized something. So spinning particle, drawing the position actually isn't enough. That is the position assuming that center is 0, 0, but we're going to actually have to pass in center. So this is going to be numvec to center. Okay, cool. So tornado ring is going to have a position. So numvec num. Oh, right, we have to import that. So, or we have to define it using numvec2 equals system.numerics.vector2. Now we can use numvec2. And this is going to be a public numvec2. And as we do for a lot of things, it will be position. Boom. So I think what we'll have is this actually doesn't even need to be public, does it? Let's make it private for now. What I'm talking about is having a list of spinning particles. Tornado spinning particle. And this is going to be particles. And then I guess right away we can do the draw. So public void draw. We are going to be passing in so, this is interesting. Because how do I want to set the position of a ring? No, I'll be setting the position. Huh. I'm trying to think about, so the rings. I'm not gonna worry about it. Basically the rings are stacked on top of each other. They have a certain offset, but then they also do the spinning thing where they go around in a circle, sort of. And I'm trying to figure out, like, do I want to do that as a method inside Tornado Ring? I probably do. So I think I'll just have position get set in a local method, and that'll just be the position, basically. It's not like particle where it's really obvious, like this is traveling around a ring and then it gets offset later. And I don't think it needs to be like that anyway. So for our public void draw, we do need, again, our sprite batch. Always need sprite batch for drawing. We need to pass that in. And then simply for each particle in particles, we're going to call the draw event particle.draw. And it's going to be batch. And center is going to be the ring's position, which is its position centered. And then that's good. And then we'll have this other thing here. So our particles have this update position. I think what we'll do for the tornado ring is this will also have an update position. So update, this will be public void update position. Okay. And maybe I want to have the height offset of the tornado ring be something else too. So, okay, so first of all, though, this does need to have a width. So, public float width. We know it's going to have a width. And then I guess we know it's going to have public float y offset. It's going to have these things. So when we do an update position, I guess what we'll do is we'll have it take in the X and Y position of the tornado itself. So this will be a numvec to, I guess we can just call this tornado, not capital T, tornado origin. Origin. Perfect. So that's pretty much all that we need to do. So we're going to update the position in a second, but first off, again, so this is the parallelization we can do. Parallel, para something. So, okay, let me do it not parallel just to demonstrate. For each particle in particles, particle dot update position, and this takes a time and a width. Oh, that's right. We'll need a time value. So let's pass that in as well. Float time. So you take time, and you also take the width of the current ring, which is just width. So time will come from the tornado itself. The tornado knows what time it is, I guess. And that's it. It's as simple as that. So what we can do, we can parallelize this really easily because we've set it up that way. And this will be parallel. Why can't I figure out how to spell this? Oh, it's 1R. Okay. Parallel dot for each. And this takes a lambda expression, which I'm going to avoid explaining that right now and just say it is particles and then x oh shoot, how does this work again? I've forgotten. I am using this elsewhere in the code, so I'm just going to look at that and remind myself what I've done. Okay, so parallel for each, you give it the list, and then... Right. Alright, so this is going to take... I'm going to sneeze again. Excuse me. Particles, and then comma, and then what we're actually going to do. So the source is particles. We could call it something like P and then give it that fat arrow, but since all we're doing is a singular method, this is technically allowed. I just got to give it the correct. Yep. And so it knows that update position is referring to... Oh, it doesn't know that. That might be because I called this update position as well. What if I call this like D update position? Then does it figure it out? It doesn't figure it out. I kind of thought I could get away with that. Okay, I can't. P, fat arrow, P dot update position. Look at that. Imagine just doing everything. And I'm actually, just for benchmarking, I'm going to leave this written here and just comment it out. So later I can see if that makes it run faster. Sometimes there's some overhead for parallelizing. And if you're not parallelizing enough things, the overhead makes it take longer than if you just did each thing in sequence. That kind of sucks, but you do have to do some work to put each thing on its own thread. It's just how it is. It'd be nice if I could just parallelize everything without thinking about it, but there's a chance that we'll have enough particles doing things that it'll matter. Anyway, so next we're going to bring up GameMaker again and look at the code that I use to tell where a ring is going to be. So where are we deciding where to put a ring? So we've got this movement interpolator. Oh, and this is quite interesting, huh? We did a lot of this with interpolators. So the actual ring on the tornado doesn't quite know where it is. So I think what I'm going to end up doing is it knows its offset position, so it'll use that basically. And we'll set a Okay, well, so this is power of movement, and then this is from 0 to 1 based on max height. So what I can do is it knows its current Y offset, and I can feed it max height. So flow, actually I might as well just make that something that it owns, because I can give it max height. Yeah, I can give it its own max height when I'm creating all of the rings, and I'll just give them all the same value. So it's going to be, I should keep with the publics though. Public, float, max, height. Yep. So movement interpolator is going to be like this. Float movement interpolator is going to be float.power. Float.pow, okay. And then I divided by number of bodies minus 1 is actually just exactly the same as y offset divided by max height in this case. Because when y offset is 0, that is directly on top of the bottom ring of the tornado. And so this is going to be 0. And then the very top ring is going to have max height. So this is going to be 1. So everything is good there. And then I do need to create this power m as a constant. So let's just do a quick private const pow m, power m, power m. And from GameMaker, we set power m to be 2. Oh, and I have to tell it what type it is. These are going to be floats. I realize that 2 is an integer, but if I want to change it, it's got to be a float. So 2. And then we have to multiply by max movement. So max movement will be another constant value. Although, wait. Oh no, this is a value that we can set actually. This movement interpolator is going to be a constant for that ring. So let's do that. So this is going to be private float movement interpolator. And what we'll do is we'll turn this y offset into a getter setter. Get set. And that way. So, and I also do want to have, I need a private value for it. So private float underscore y offset, just to have it equal to something. So actually I don't need to do equal 0. So whenever we set y offset, it's going to get the value of underscore y offset. And then when we set capital Y offset, it's going to set underscore Y offset equal to the value we're setting to. But it's also going to do this math for us and set the value of movement interpolator. So this is going to be movement interpolator is equal to this. And then I don't know why I put a 2 there. The whole point of making a constant was to, yeah. Power m, and let's multiply by max movement. So times, and we're going to make max movement a constant once again. So this is going to be private. Ooh, I don't know what that was. And actually, I kind of want to keep constants together too. That just makes sense. Private const max movement. I'm sorry, this is also a float. Floater. And we set max movement to 7.5. That's what we were happy with. 7.5. So that needs to be an F. And this is going to be times max movement. Great. And then the circular movement value is, so wave precession. I should probably just set all these constants right now. I don't want to keep having to deal with it. So we do have power m. We have 3 power values. We have w, m, and h. So w, m, and h. And they are, sorry, w, h, and m. Just to keep it consistent order, sort of. And W, H, and M are 1.4, 1.8, and 2. So 1.4, 1.8, and then, of course, 2. Oh, look at this state value. I never actually used this. That's weird. Oh, no, I'm sorry. Wow, I can't believe I forgot. I was using state for debugging. That's so funny. Okay, anyway. Oh, you know what? I kind of baked in the ratio, but if I want to change the ratio later, let me do that. So private, const, float, ratio is equal to 3. So this is the ratio of width to height, and when I'm updating the position of my particle, I am not considering the ratio, basically. So I want to divide this by ratio. I'm actually going to make that something else that gets passed in. So float ratio. This is divided by ratio. And then rather than dividing by 2 in both places, I will just divide by 2 after I have finished creating the vector 2. And that will... Actually, it doesn't really save me all that much, but I think it looks neater. It tells me that everything's getting divided by that same 2. And then just the height is getting divided by the ratio as well. So it's getting made smaller. Okay, and then this needs to take ratio as an argument. Boom, like that. So now we can change the ratio what we want, and we don't have any magical numbers floating around. Okay, so now we need some more max values. We've got private, const, float, max, width, which is going to be 105. We have private, const, float, min, width, which is 15. We have max height, which is 90. Private, const, float, max height, 90. And how else are we doing? Oh, number of bodies. That'll be something that my the actual tornado baddie will have to handle. So that's fine. And then time is also something that the tornado baddie will handle. But wave precession, that's another constant we can use here. Private, const, float, not ratio W. What am I currently hitting backspace on? Wave precession equals 20. That's a 9. Cool. Oh, and then number of particles scalar. Right. Private, const, int. No, not int, float. Num of particles scalar is equal to 0.5 is what we came up with. So when we set the y offset, we'll also be setting the width. And when we set the width, we will be creating all of our particles. So let's do that now. So we'll make this another getter setter type dealio. So we'll add a private version, float underscore width. Precisely. And then we'll have a getter, which is going to return the width. And we'll have a setter. Come on. Set. What did I do wrong? Oh, this needs to be a fat arrow. Set. So yes, width does equal value, but on top of that, underscore particles is going to be equal to an empty list at the beginning. And then for int I equals 0, I is less than. So how did we end up doing this? It's here, right? So number of particles is going to be this floored. So number of particles scalar times width. So we'll do int num of particles equals, and we actually don't need to floor this. I don't know what I was thinking last time. So flooring is just an extra erroneous step. If j is less than, even if j is an integer, if j is less than a floating value, then it's less than the floating value. So it doesn't matter at all. So number of particles scalar. Let's do num of particles scalar times, and we're going to use our width. So times width. And I'm not worried about this being an integer, like I said. So as long as I is less than this number of particles, I plus plus, then we're going to add a particle with all these properties. So we're going to say var part is equal to new tornado spinning particle. And then we can say part dot a velocity. Let me actually realize I'm not showing things here. Yeah, this will just make it easier for me. And I'm sure you guys are getting nauseous with me alt-tabbing constantly. So we are going to have to bring in a random value. So let's do that. So public tornado ring. And I'm going to have it know about game. So FNA game. So this is the actual scheduler. And the important part about the scheduler is that it has our universal random number generator that we use for everything. So if I add something down here that's like private random, then I can set it to be a reference to the random value that we use everywhere. So this is going to be program, because it's actually program game random. So what's happening here is program inherits from game, but program is the one with the random value. So if I'm going to be importing FNA game as the argument, then I need to let it know at some point that it's actually coming from program. It's not coming from the base FNA game class. So that's how you do all of this. It's kind of silly, but there it is. But now I have random, so we're good. So we got a velocity, and we're going to use all this randomization. So a velocity is going to be equal to -3 times float.pow, and it is our current width array, which in this case just translates to our width, power of width, raised to -0.3 for some reason. I mean, I know the reasons. It's what we ended up putting in Desmos, but it do be just a random floating number, which we try to avoid, but sometimes it doesn't make sense to worry about it for this one-off equation. Same thing. Whoop, not that. Random dot next. So next double is a double-sized floating point. In an update to C#, they added next single, which I am very happy about because it means I don't have to spend time casting things anymore. And I'm just going to grab all this because it's all the same. But I do need to put Fs in here to tell everyone that we're using floats. Okay. Wow, what are you upset about? Oh, right. So this returns a value from 0 to 1. I have to multiply it by the range that I care about. Slightly different from how GameMaker works. That's okay. So that's our angular velocity. Our part dot initial angle is going to be a random value from 0 to 2 pi. So we're going to do another random dot next float, next single, times float dot tau. And there we go. And then that's our initial angle. I believe the way I did it was just our first actual angle is just going to be our initial angle. So initial angle. Then we've got color. So part dot color. Okay, this is where I'm going to choose between a few different things. So if you open up GameMaker, some of our color options looks like the following. So this is 192, 192, 0. So I'm going to make a bunch of colors. So we're going to do a switch. I'm sorry, not switch. We're going to do int color picker is going to be random.next, and this is a next integer. And we had 1, 2, 3, 4, 5 different colors we were working with. So I'm going to do 5 here, so that'll pick a value between 0 and 4. And that's fine. And then what I'm going to do is make a switch case for color picker. And what I like to do is I tend to set case 0 to just be my default. So we'll say default, and then what we'll do is part.color will be new color, and I don't want it to, if I hit enter there, it's going to just make the line super long and not actually add a using statement. It's just going to add like a one-off. So I'd like to do that instead. And like I said, right, this color was 192, 192. So we can do that here. Color is 192, comma, 192, comma, 0. And that'll be my 0 case. Then we'll do case 1. And so that's not just my 0 case, that's also my, for some unbelievable reason, color picker got set to a value that isn't legal. It's just, I guess, hedging my bets, but this is kind of the same. I'm probably going to want to choose more interesting colors later, but for now, this just gets the basic idea down. This is 64, 64. So, okay, wow, I really was unoriginal with this. It's all just darker shades of the exact same color. If you didn't know, if you take a color, like 128, 128, 0, and you multiply everything by a constant value, in this case 0.5 for example, it's still the original color, you're just making it darker. It turns black. Oh, we have chatters. Beepy Smeepsy just did their first water change on a fish tank. The muck, the slime. Originality is for chat, sorry. I don't even know how long ago that was posted. I hope your fish tank change went well. And didn't traumatize the fish. I'm kidding. I don't... I guess you could change. I guess you could traumatize fish that way. Pretty sure I've heard of that. I hope you didn't traumatize your fish. Anyway. So I've got 2 more of these colors to worry about. Oh, this is just straight up black. Okay, that's fine. The fun part about black is I don't have to make it a new color. I can just use color.black. Wow. The fish are thoroughly traumatized. Wonderful is what we like to hear. $255, $255, and $128. So grab you. This will be our last case, 4. That says 4. And this is going to be all of the numbers I just said. 255, 255, 128. Okay. I was rage baiting them the whole time. Like with actual fishing bait, or sorry, that was pretty bad. I apologize. I did my worst here. Anyway, we are now choosing a random color, moving swiftly along. Next, up. Where are we? Here. We just did color. Okay, now we have to set a position, which, I mean, we might as well just set an initial position, right? So position equals, actually, yeah, let's set an initial position. So we'll do position is equal to part dot update position. Oh, actually, that doesn't return anything. It's just part dot update position. And this simply takes, oh, this takes a time. Well, time is 0 because we just created it. Haha. Width, and then ratio. And then that will set our position to something. That'll also set our angle. So maybe it's not important to set angle up here. I guess I'll get rid of it. Goodbye. I missed you. Okay. That was a huge tangent to set width. Is that everything I need? Maybe. Possibly. So we've got height interpolator. So this is going to be... Oh, right, we're doing our update position. So before we can update the position of our particles in our list, we need to update our own position. Actually, I guess we don't need to update our own position to do that. But we do need to update our own position to have an updated position. Because otherwise, if we don't have an updated position, our position will not be up to date. So it's very important to do whatever it is that I just said. I don't actually know. Oh yeah, we're not drawing this to a surface now, so we don't have to worry about this. So, did I actually end up setting movement interpolator? Yes, I did. Okay, circular movement value. So let's look at things here. Wave precession is a constant. Height interpolator array is just going to be the height interpolator for our the actual ring. So I do need to set that. And that gets set when I set Y offset. So we just did movement interpolator. Now let's do height interpolator. I forgot that I need to actually create that. So that goes under here. Private float. I need to initialize this as height, or instantiate it as height interpolator. Coolio. And then height interpolator is going to be equal to this, which is just power. Okay, see, so this is it's where it might get interesting because I'm not doing a good job of indexing stuff. Although, oh no, wait. So this is what we were talking about with Desmos. So let me actually pull up Desmos again. Desmos, my beloved. Desmos. Okay, so let's remind ourselves what these graphs look like. We have y is equal to, so this is for height interpolator, right? This is divided by, we've got I to the power of h, and then we have number of bodies, b minus 1, to the power of, again, h minus 1. H minus 1. And I is actually x, so let's do that. X to the power of h. We are going to add these things together. So, if h is a number like, well, let's just use the actual number for h, I guess. 1.8. 1.8. And b is the actual number of bodies, which is 24. 24. Yeah, you can't use 0 because then you have, well, you can't use 1 because then you have 0 in the denominator, and that's not great. So, yeah, I'm trying to avoid using I right now because I want to base everything off of the height of the, I want to base everything off of the actual height of the ring itself. So my thought process is what is my thought process? So if we look at where we're using height interpolator, it's going to be oh man, wait. I'm starting to psych myself out on this. So basically, what I'm trying to say is we're using the x. So we have x here is a value from 0 to b minus 1. So you can kind of think of this as like we're dividing x by its maximum value. But the fact that it's being raised to a different power kind of... Wait. Yeah. The fact that it's being raised to a different power makes the math weirder. But if you remember what we're actually doing, the basic graph is actually this. It's just x to the h. That's the basic graph. That's it. And we're just performing some interpolation. So basically, wait. I'm freaking myself out. For smooth and for true, can't even speak. Chatter asks for smooth transitions. So this is the distance between each ring. That's what this graph represents. So as you get towards closer to the bottom of the tornado, individual rings will be closer together. And as you get further towards the top, up to 24, then the rings will be further apart. So because the rings are gigantic towards the top of the tornado, spreading them out like this makes it look better. But it might just be worth having an indexed value. Oh my gosh, what am I talking about? Y offset literally comes directly from the height interpolator. Oh my gosh, I'm actually so funny. If I'm setting the height interpolator, I already have everything. Oh my gosh. If I'm setting the height, rather, I have everything. Okay, so this should be opposite. I shouldn't be setting Y offset and then getting height interpolator from Y offset. I should be setting height interpolator and getting the Y offset from that. Then it'll be one-to-one with GameMaker, and I don't have to expose to the world that I don't know how to do math. I mean, I knew how to do the math, but, you know, this is just better. Yeah. Yep. Shut up. So let's stick height interpolator here. And this will be HEI GHT interpolator. And we are going to get the value of height interpolator. Yeah. Don't you make fun of me for being silly. I can't even... What are those emotes? I don't even know what that is. Anyway. So we got our height interpolator. So, okay, obviously height interpolator is going to be this. And then we can get everything based off of the height interpolator like we're supposed to. So the actual ellipse offset Y array comes from height interpolator. So we're setting height interpolator. We'll be setting that when we create the tornado ring from within the tornado itself. So that's fine. More importantly, Y offset. Backspace everything here. Oh yeah, capital Y offset doesn't exist anymore. More importantly, Y offset is going to be equal to height interpolator times max height and this is saying divided by number of bodies minus 1, but that's stupid and lame. Shoot. I didn't want to have to set the number of bodies. Do I care about the number of bodies elsewhere? Am I fighting a losing battle here? I don't, right? Maybe what I do is I set both height interpolator and Y offset inside tornado. And then when I set Y offset, I will set movement interpolator since that uses that. That's what I'm going to do. So we'll do... Oh, but I set max hay. I set max height here. I'll cross that bridge when I get there. So I'm setting Y offset elsewhere. We'll do public float Y offset get Y offset and then set will be more complicated, but of course we start with Y offset equals value, and then we're going to paste that there. Movement interpolator. Fantastic. It's starting to come together. It's really weird. I feel like what I should be is bouncing back and forth between the tornado ring and making the actual tornado. But I don't know. Somehow setting it up like this is the vibe. This is also an insanely long amount of time that I have. I don't think I've tested my code in over an hour. But I mean, I'm just copying and pasting. It shouldn't matter, right? Right? It should be the same. Should all just be okay. Right? Anyway, vibe coding works. This is not vibe coding. Vibe coding is when you use AI, and AI coding is for lame people. Lamey. Copy and paste only for it to be completely broken. I'll admit I'm vibing. I am vibing. The music goes pretty hard, but I need a longer playlist because it's already looped twice. No, vibe coding is not spaghetti code. Vibe coding is when you completely shut your brain off and just let the AI take over. And anytime you have a bug or some functionality not what you wanted, you just put it into AI and blindly paste in whatever it tells you to do. You just don't think about it at all. You're just vibing and letting AI take over. That is vibe coding. And it's disgusting. This has been my opinion, by the way. Anyway, we need to do circular movement value, which is wave precession times height array times height times time. Okay, so this is a function of time, so we actually do need to calculate this one. Circular movement value. So float I'm anti-vibe coding now. Yeah, we're all anti-vibe coding. It's very sad. Circular movement value. Circular movement value equals wave precession, right, that's a constant I forgot, times height interpolator times float dot pi divided by max height. Wait, why is that not? I thought you were a constant value. Why are you not a constant? Go away. Max height plus 2 times time times pi divided by 30. And I know that premature optimization is the root of all evil, but I did notice I'm multiplying by pi twice, when I probably shouldn't have to do that. Yeah, I definitely don't have to do that. So let's take this pi out and this pi out, and let's just multiply the whole thing by pi at the end. Premature optimization, let's go. Let's freaking go. Removing a singular multiplication from my otherwise horrible code. Wave precession times height interpolator divided by max height. We took out the pi. Yep. Okay. Next up, this doesn't need to be center x and center y. This can just be numvec2 center. Numvec2. Oh no, wait, it's not center, it's position. We're already doing stuff with this. We already have position. Position is equal to all of this. So right, so this surf x and surf y value are because we were it's got to be offset from the top left / top right of the surface, but now we should be I'm trying to think. Oh no, that surf x and surf y is the tornado's position. So we do need to get the tornado's position. Oh, wait, I have tornado origin. I almost added an entire new argument for absolutely no reason. So it's tornado origin plus new numvec2, which is movement interpolator times cosine circular movement value. Movement interpolator times float dot cosine circular movement value. Whoops. There we go. And then the other one is just ellipse offset y, which in this case is just we just renamed it y offset. So this is going to be minus y offset. Surf X and Surf Y sounds like combat surfing, tactical surfing. Surfs and surfy. That's what it is, actually. Oh, these max heights are wrong now because they're supposed to be constants. Max height. I realize it's taken me like so long to copy this code over and like I guess slightly make it better. I'm probably gonna have to cut the stream short before I even get to run and see if it works. Oh, that's so sad. No, we're gonna get there. I don't care what it takes. We're gonna get there. But this is already like an insanely long stream. I just gotta dial in. Let's just get it done. Let's get it done. So that's position. Ellipse height we don't care about. Center Y is now, we're going to, okay, so we're adding a value. So it's going to be Y offset, but also plus float dot sine of circular movement value, circular movement value times movement interpolator divided by 3. And that's going to be minus Y offset. Yes. Yes. That's going to create the rotatey kind of effect. And then we don't care about x1, y1, x2, y2, because that was for actually drawing the ellipse to the screen. So we're actually done here. That was it. That was it. So that's it for the rings. Now we need to go into Tornado itself and create a bunch of rings. So where's my Tornado? OBJ Tornado. So I think what I'm going to do, so the do update is important because that comes from when you're doing infestation mode and you press space, it freezes the game. So anything in do update will not run while the game is frozen. But I do want the particles to continue to swirl around the tornado because otherwise it just looks weird. So we're going to do public override regular update, and this will run no matter what. So first of all, our tornado does need to have a list of tornado rings. So we'll just call this rings. And we're going to say, okay, so actually when it's created, we need to initialize rings. So let's do like just to keep the code looking kind of okay. We'll just do a private void init rings. And we'll do that, I don't know, here maybe. I like to do, whoops. I like to do depth at the bottom, just in case anything causes it to change position. It should update its depth last, but that shouldn't matter for this. Anyway, so first of all, we've got our number of bodies. So num of int num of bodies is 24. And then we can oh my gosh, I forgot something really important. When we're doing this, when we initialize our part, we actually have to add it to the list of particles in the tornado. Otherwise, we're just creating them and then not doing anything with them, forgetting the reference to them, and sending them straight to the garbage collector. So we need to do particles.addPart. Look at that. Visual Studio literally knew that's what I needed to do. I completely forgot about it. Okay. So let's go back to our tornado. Let's make that closer to everybody. So for int I have caps lock on for some reason, equals 0. I is less than number of baddies. I plus plus. Go away, random extra parenthesis. So we're going to do this. We're going to say ring, var ring is equal to new tornado ring. And this does require that I pass in game. Okay. And then we can do ring dot, we need to set the height interpolator, I believe. Yeah. So ring dot height interpolator is going to be equal to, I'm just going to copy and paste this and then fix it. So instead of pow, it's float.pow. That's positive infinity. Float.pow, power h, shoot. I'll just make it public. Power h, because this is a constant, right? So I'll just make this a public. So this is now tornado ring dot power h, and then this is float dot pow again tornado ring dot power h. Cool. So that's our height, and then if you remember, yeah, so that's going to set our movement interpolator, and then we can set our y offset. So we're going to do ring dot y offset is equal to height interpolator array. So ring dot height and wait. Yeah. Ring dot height interpolator times okay, so max height I need to make public as well. So max height will make you public. Tornado ring dot max height divided by number of bodies minus 1. By num of bodies minus 1. Perfect. It's either incredibly smart and already knows how to make my entire game, or it is listening to me because wow. And then I believe this will create the width, right? Who's creating width? My width interpolator array. Is that not even a thing? It's not even a thing. Where do I use this? I'm using it there. Guess I'm not using it anywhere else. So I'm not setting my width. I have to set my width inside of Tornado. So we're going to do float width. This is therapeutic, like study with me streams. Yeah, exactly. With interpolator array. I mean, I imagine if you really were like, I just got to know what his workflow looks like, you would be listening. But otherwise, I feel like I'm doomed to be a background streamer. Current width array is going to be float.lerp, but we'll make some good videos out of it. So min width, max width, yeah, so that's going to have to be public as well. Public, good. So lerp, so something between min width, we'll say, you're not much of a background streamer, I'm just sleepy. Well, thank you. But you are more than welcome to sleep through it as well. Max, not max height, max width. Max width. And that's going to be, wait. Oh my gosh, I started making current width. I'm on the wrong line. I'm so funny. This goes here. And then this is width interpolator, not array, just width interpolator. And this is going to be ring.width, but we're not actually there yet. So width interpolator is, I'm just gonna, again, copy it. And then I changed ellipse offset to just be y offset. So this is gonna be ring.y offset. This needs to be float.pow. That says parse. I don't even know what that does. Also, did I do this correctly? I'm traumatized and paranoid, like all coders should be. Max height, oh, I'm sorry, tornado ring dot max height. And then now this power W needs to be made public as well. And that's, I think, the last piece of the puzzle, because that's the only one that's still grayed out. Tornado ring dot power W. Good, good. We've got our width. And then we already initialized all those parts. So yeah, this... Gosh, okay, this should be it. So this is init rings. And then in update... In update, we're going to do another parallel for each. Parallel dot for each ring. Oh, I almost forgot to do it again. Oh my gosh. Rings dot add ring. Really important. Really important to do that. Okay, so for each rings, ring r dot update position, and you require my own position, which is tornado origin. Oh, and then time. I have not made the time value yet. Let's do that. No, not chill max time. Let's just pretend everything is okay and just set time. Okay, so we've got this private float time value. And so something kind of important, kind of interesting. I did have time increasing by 2 every single step when I was using GameMaker. And I realized today that was kind of fortuitous because I had the GameMaker game running at 30 frames per second, and this runs at 60 frames per second. So now if I set the... Now if I set time plus plus, it'll be perfect, basically. So I can just do that normally. So there's this tornado. What I'll do is after each update, I will increment time plus plus. And then the last thing I need to do is call the draw event. So override. So for a game object, it actually has a draw event. And I think I might have to get rid of this base.draw. I guess I don't. Although it'd be weird if the tornado got frozen and turned to ice. That'd be really freaking funny. Okay. So last thing we need to do is for each var ring in rings. Thank you, Visual Studio, for always already knowing what I want. Ring.draw. Fantastic. What am I even here coding for? Why do I exist? By the way, that would be unironically comedic. Like, what do you mean the wind froze? Yeah, no, that'd be... Oh, it's just frozen wind. You're so right. Anyway, sorry. So, I did at some point try to parallelize drawing things, and it goes crazy. If this works, I'll parallelize it just to show you guys at the end. But there's no way this works. I haven't gone back and checked everything or like really thought about it. Yep, there we go. Are you not? What do you mean? Oh, I'm sorry. I need to do rings equals an empty list because it doesn't exist yet. Dot. Okay, now it's just simply mad at me. What did I do? Oh, this is just Visual Studio freaked out. That's not even my fault. Unless it is my fault. That'd be weird because I didn't change anything. Yeah, cannot access file. Okay, so that happens sometimes when it crashes. I think what's happened is Visual Studio has still marked the file as being read, so I can't get another application to read it, and that other application is once again Visual Studio. Yeah, I don't care. So let's do this again. Yeah, the documents version. Bum ba dum, bum ba dum, bum ba dum, bum ba bum, bum ba bum, bum ba bum. All right, and after all that work, it doesn't do anything. Heck yeah. Uber forgot your fries? That's terrible. No way. Can you make Tornado do get my fry? Let's see. Tornado. Let's just do public void get fry, and then we'll just leave a comment here to implement this. And then during our do update, we will just do a get fry. And actually, we can make that private, so that's good. Cool. All right. You better watch the streams if you ever want to know why get fry exists. Okay. That's okay. Just calling a method that does absolutely nothing doesn't take up any process. I mean, it does technically, but it's kind of nothing. Just adds it to the stack and then throws it away. Okay, yeah, so the big question is why? Tornado? What's going on here? What are you doing, bro? What are you doing, bro? You should be drawing all of your rings. Okay, well, let's play the game. Are you even getting here? Yes, you are getting here. What? What's your position? Oh my goodness. I went through all the trouble of getting the center of the ring, and I'm not adding it to the position. So if I had gone to position 0, 0, like all the way in the top left corner of the screen, I probably would have seen the tornado. Very sad. I actually did the exact same thing when I was in GameMaker. I forgot to do that twice. Oh my gosh! Wait, why does that look so good? What? Why does it look so good? Okay. One last thing. So I'm actually going to get a new color, and I'm going to utilize color.red, color.green, and color.blue, which seems stupid, but I'm going to be setting the alpha to something smaller, like 63. So it's like 25% opacity. And then I can finally be free and go to sleep. Okay. That's pretty good. That's pretty good. So, so kind of the next thing I want to do is, I kind of mentioned last time, so there's no, there's no depth sorting with the tornado. So, like, obviously I'm behind the tornado. Oh my gosh, that sent me flying. And I can be in front of the tornado if I'm here. You can see it for a split second. But there's no depth sorting with the individual particles. I don't think it'll be necessary, but I do want to attempt to add depth sorting to the tornado. Even if it slows the game down, I just want to see if it makes a big difference, because maybe it's something I want to consider in the future. Why is it pea colored? That's a really good question. Anyway, guys, I hope you enjoyed the stream. I'm going to sign off here. Next stream, probably Monday. Probably. Maybe Sunday. If I can get some good video editing done, I mean, if I'm coding, I'll be... Oh, right. I forgot I can kill the tornado. Right. Yeah, Monday stream. Or Sunday stream. Sunday stream if I'm done video editing. But I'm going to be gone over the weekend without my setup, and I'll probably be working on the game. So, next time I stream, whenever that is, I'll catch you guys up on what I did off camera, basically. And that's pretty much it. I hope y'all enjoyed. I'm really sorry for that one person who just joined the stream while I'm wrapping up. And that's it. Thank you. Thank you, everybody, for... how do you end a stream?